Hi, I'm Shane in Sweden, and this is the second part of our series of presentations on security unit testing automation with Selenium in C#. Now, in the last part, we introduced Selenium and why we might want to use it as a security testing tool. And we had a look at how you could use Selenium to automate the process of handling a complex user case. In the example we had chosen, it was a wizard, and how you could use Selenium to navigate to obtain the content you wanted to test. In this part of the video, we're actually going to use Selenium to do some simple security testing to show how we can actually build a very, very simple vulnerability scanning function for our own web applications. So let's get started, and I hope you enjoy it. So what is CSRF? Well, CSRF or CSRF as it's sometimes called is an attack that a user may not actually even be aware of. They may not be aware that it's happening. A CSRF attack forces the logged on user, and it's important to remember that the user must be logged on. It uses their browser to send a forged HTTP request, which includes the session cookie or other authentication information that's present to the vulnerable web application. And the vulnerable web application receives the request and processes it, assuming it to be a legitimate request from the victim because it comes with the correct authentication information, for example, a cookie. And we're going to use Selenium to test for our web applications to see if our forms are vulnerable to this type of attack. So how do we test to see whether or not our web applications are vulnerable to CSRF attacks? Well, in the particular example we're going to look at now, we are looking at MVC applications, for example, in this case with ASP.NET Core, or ASP.NET. And ASP.NET and ASP.NET Core actually provide good protection. There's a number of ways to implement anti-forgery defenses in a web application. So for example, here's one example. When you're building a form, you can use a anti-forgery token HTML helper to add protection. Okay. Now, when you do this in an ASP.NET Core form, for example, what actually happens is that ASP.NET Core adds a hidden form field to your web application form. And so we can look for these verification tokens in our request verification tokens in our ASP.NET Core or ASP.NET MVC applications. And we can check then if our forms are actually protected against a CSRF attack. So we could have, as part of our development process, we could have one of the items in our definition of done for our development teams that whenever they build a form in a new form in a web application, that they have to make sure that the form is protected by CSRF tokens. Okay. And then we could also have as a backup stage, just to make sure nothing passes through, nothing slips through the net, we could also have some sort of vulnerability scanner which scans our web, all the pages and all the forms in our applications, web applications, and checks that each of those forms is protected by some sort of anti-CSRF forgery token. So how would we put in place this type of vulnerability scanning? Well, there are a number of options. We can purchase a scanner. Like Unitix, for example, has a very popular web application security scanner, which would identify possible CSRF vulnerabilities in your web forms. Another security scanner that I have experience with is Detectify, and it'll also detect these things. And these tools are very useful to have as a control and a check on your applications, but it is possible to build the same control yourself. And you can do that, for example, using Selenium. And so that's what we're going to look at today. Can we detect missing CSRF tokens in our form applications with Selenium? So let's get right to it. Okay, so we're back at our unit tests here in our Visual Studio, and we're going to build a new unit test that'll check a web page and will give us a result. So create a new unit test. And this is still going to be Selenium. Now we're going to check a good web application. And it should pass our test for CSRF. And let's do our arrange. And assert. So we're going to do some sort of creation, set our list of the URLs that we're going to pass in. And here we're going to test that list of URLs in turn to see if we've got the correct CSRF protection in place. So we're calling our web utils. And the result should be true. Now we need to pass in this test. We're just going to pass in a URL for a web application that we know is good. Now normally we would have our list of URLs that our company is producing as part of our web applications. But in this case, we're just going to pick up a URL that we know is a good, well-protected web application to demonstrate our test. And here we have a web application, which we've found, and we know that this is well protected against, it has CSRF protection in place. And if we look at the page source, and if we search for the form elements on the application, we can see we've got 7 forms. And if we look in that form, we can see indeed we've got the request verification token, anti-forgery token. And if we go to the next form, see there it is also protected. And the third, and the fourth, and the fifth, and the sixth, and the last. So each of the forms inside this web application are protected using ASP.NET anti-CSRF forgery tokens. So we've done that manually, but can we do that automatically with Selenium? So let's just copy the website code. And let's pass that into our list here. So at the moment, our list is just one website. Okay, so we're going to generate our method. And we're going to run our test, which should fail because we haven't implemented anything in the web utils. This method or operation is not implemented. Okay, so let's go to the method. And now we're going to create some sort of test. How do we test? Well, we're going to use Selenium to go to the website and check the form elements. So first of all, we want to init driver. We're creating our Selenium WebDriver. And then for each URL, to test one URL with our driver. And if it's not true, if it fails, if any of them fail, then we return false. Otherwise, we return true. So let's create this method. Right, so how do we know if all the forms are protected? Well, first of all, we need to identify how many forms there are on the web page. So int number of forms is equal to we can just pass the driver to that. Here we're going to load up the URL, so it'll be driver.url. And here we'll have also the number of CSRF tokens. Then if number of CSRF token is equal to the number of forms, then we can return true. Otherwise, we return false. Now, this actually is not a great test. There's a number of issues we're not dealing with here. For example, we may have a form that's not using post. As a simple demonstration, I think it'll still be effective. So we want to find the number of forms that are existing at this URL. And then we want to look at the number of tokens and see if the number of tokens matches the number of forms. So how do we identify the forms on a web page or web content? Now, in the previous video, we used different search methods in Selenium: find element by ID, find element by name, and so on. In this, we're going to use something called a CSS selector, which is quite a powerful method in Selenium for identifying elements from a HTTP content. When we're looking at any elements that we've got, any HTML element in a form, we have a number of sub-elements. So for example, we have the type of tag. And in this case, the type of tag here, it's an input. And then HTML element will have attributes. Here we've got 4 different types of attributes. We've got type, we've got ID, we've got name, and we've got a class. Okay. And then these attributes have values. So the value of the text, or first name, or first underscore name, or my form. And Selenium we can use Selenium CSS selectors to actually identify elements in our HTML from these different types. General method in creating a CSS selector here is we're looking for the element name, which is, as we described earlier, it's the tag. Then we're looking for the attribute inside that element and some sort of value. So for example, if we wanted to find this HTML element in our web content, we could search for an input, which would match onto that type of tag. And we could search for names equal to first name, and that would identify this row, or identify all the rows in the HTML content that were of type input and have an attribute called name, which has a value first name. We can also search for multiples, so we can search for names equal to first name and classes equal to my form. So you can see it's a very powerful search method. So in this case, we want to find the number of form elements. And so we can do the same thing. We can do driver.find elements by CSS selector. And here we have to give it the string we're going to find. Now we're looking for form elements. And if you remember here, when we're looking for our input type tag, then the CSS was input. And then of course there are other values and attributes, but at the moment we're just interested in forms. So it'll be the CSS text string here we're looking for will actually just be our, instead of our input, we're looking for our form. So we can just fill in form. And we want to return the count. So the number of form elements we find. But I've actually just noticed there we're in the get number of tokens method, not the get number of forms. Let's just paste that in there. Okay, so we come in and we find out the number of forms elements. Let's just check that that works by going back to our test. And we know that the application has 7 forms. So we initialize our driver and it starts a browser. And then for each of the URLs, and this is our URL, we're going to test one URL. And that means we come in and return the number of form elements. And that's 7. Okay, so that's good. Now the question is, how can we identify tokens? Well, let's look at our web content again. If we view our source, and we were looking for our forms, and here we can see we've got an input. So we have an input tag. So before, when we were searching for the form tag. Now we're searching for an element of type input, and we can see we've got a specific attribute called name, which is request verification token, and also another attribute called type, which is hidden. So we can use these two attributes on the input tag to try identify the number of anti-forgery tokens we have. So if we come back to our method, we can do another CSS selector. So we're finding elements by CSS selector, and we're looking for input tag, and this time the input tag has got an attribute which is name and type. So the name is request verification token, and we also have the type which was hidden. And we want to return the count on that. So let's test that. So the number of form elements is 7 as before, and the number of tokens is 0. Okay, something's gone wrong with our selector. We're just going to try this again. Be more careful with the way we copy and paste. So at the moment we're looking for an input, and the input has a type which is equal to hidden. And also a name which is equal to request verification token. So just paste that in to make sure it's correct. So, which is the same as we had before, but perhaps we had some sort of spelling mistake. But let's just check that again. Okay, so we have the number of forms is 7, and the number of CSRF tokens, anti-forgery tokens, is 7. Okay, so now it worked. And we can see that every form we have is protected by an anti-forgery token. So we're able to test now to check that our developers haven't missed any forms that they're completing, and that all the forms have anti-forgery tokens protecting them. And we can do the same test again, but this time we'll do it with a site where we know we'll fail the test, just to check our results. This time we're going to check a web application, and it's going to fail the CRF. So for our next example, we're going to use Microsoft's IIS forums website. And if we just take that URL, and if we paste it in our URLs test, and here we want to guarantee that the result should be false. And if we run that test, it starts up the browser, checks the IIS forms page, and we can see the result was indeed false. So the test passed. Why is the result false? Well, if we go to the IIS forms page here and we view our page source, and we search for each of our forms, we can see that there are 2 forms, and we can see that this first form, which starts here and closes here, this does not have an anti-forgery token. And if we go to the next one, the next form, this does have an anti-forgery token. So since both forms aren't protected by anti-forgery tokens, our test result will be negative. Now, it's quite possible that the form doesn't need to have an anti-forgery token, or there may be other protection mechanisms in place. But it'd be very useful for the developers to be able to get a warning when that situation occurs, so that we know that all these decisions are being made consciously and not just something has slipped through the process. So this is a good example of how Selenium can be used for security testing. In this case, we're examining CSRF tokens. There is, however, one area where Selenium is not so good, and you need to be aware of that. One area where it doesn't work, of course, is where the web application is protected by Google's reCAPTCHA. So if we go to, for example, Google's reCAPTCHA demo, if we go to example the invisible, so here we have a form, and you can see here it's protected by reCAPTCHA. So if I change that to an A, and then change the other example to a B, and then I submit, right, you can see the result was a success, which means that Google does not think that this is, or that I am a robot, okay? And so I'll be allowed to submit the form and proceed. But what happens if we do this through our Selenium? Well, we can create a new test. And I'm just going to paste this in. And remember, this project, everything will be available in the links down below. Okay, so what we do in this test is we go to the same reCAPTCHA, then we wait, we find that link for the invisible reCAPTCHA test, as we did. We'll enter an A, then we'll enter a 3, and then we'll process the application. And we'll see if Google detects that this is actually a robot. So it starts a browser. Should go to invisible. Should fill in A and then 3. And submit. Boom. And immediately Google senses that something's wrong and asks us to engage with the reCAPTCHA verification control, which did not happen the last time. So you are going to have difficulties using Selenium in forms in areas where your application or your developers are using CAPTCHA protection. Just something to be aware of. So that was a quick demonstration of how you could use Selenium to create a security tests. The type of security testing is a standard feature in commercial web application vulnerability testing suites. And it's good to actually understand, even if you are using a commercially bought product, how these things actually work under the hood. So I hope you enjoy this, and I hope you can download the code down below and run through it yourself and try a bit of building your own security tests with Selenium and C#. Thank you very much.